I've been quiet, but I've been coding. And today we are going to build a full desktop application. Actually, we are going to scaffold it with full CRUD, create, request, update, and delete. We are going to use Tauri as our cross-desktop toolkit, which is going to allow us to use native web components in the frontend and Rust in the backend, which in turn is going to allow us to use SurrealDB as our Rust embedded database. And all of this with hot reload. So for example, here, if we want to add a red border to our app view, we're going to do a border, solid 1 pixel red, press save, and then we get our red border. We can also change our TypeScript files. So for example, here in our task data table custom elements, we're displaying the title here, which is displayed over there in the data table. And if we want to prefix it with exclamation mark, for example, press save, and then we get our exclamation marks. Obviously a little bit silly, but pretty cool. And thanks to Tauri, we can even have hot reload with the Rust code. So for example, if we go to our project backend Rust code, we can change what comes from the database. We're going to prefix it with format, ++, and then we give the name from the database, press save, application gets rebuilt and restarted, and we get our ++. Now that is pretty cool, but it actually gets better. Everything has been scaffolded by the Awesome.app command line. You can find more information on Awesome.org, and it's basically Rust templates for building awesome applications. We are starting with a desktop application with Tauri 1.x. We will do mobile application when Tauri 2.0 will come out, and we will even do cloud application with Kubernetes. And best of all, with the same code design. If you scroll down, super easy to install, create, and code with hot reload. And then you get a full desktop application with a simple and scalable code design. Okay, enough talking. Let's start coding. So we're going to create the app, do a code overview, and then do a full code walkthrough. So first, we're going to install the Awesome app. So we do a cargo install, Awesome-app. That will download, compile the code, and install it. Then we're going to do an Awesome app, new, and we give our app name. Here's my app. Press enter, it's going to ask us the title, we're going to use the same one, and that will clone the app template and set everything up. Everything is open source, MIT or Apache v2, so you can make it your own. Then we're going to go to my app, and then we're going to do Awesome app dev. That will compile everything and start the hot reload session. At first it might take a little while, but then it goes much faster. And then you get your app, you can play with it, uncheck task, delete task, and then create new ones. So you get the full application. So let's close this application for now, and let's go to VS Code, we do a code dot, and now let's see our code layout. So first we have our source story, which is our backend with Rust and the Tauri toolkit. Then on the front-end side, we have source-UI, which has our native web components and the TypeScript. If we look at our backend code, and we zoom in into the source files, we have three main elements. We have the model, the event, and the store. And in a way, everything else around those is just to support these three elements. And now on the UI side, we have our CSS file, Postcss files, and then on the source, we have the model, the event layer, and the view layer. And then the views are native web components, and the best practices is to have the file name matching the tag name for the top elements. Now this view model event store architecture actually scales extremely well, regardless if you are doing a desktop apps, mobile app, or cloud application where the front end is over the network of the backend. And in fact, during new development, most of your time on the front end will be spent on the view, and most of your time on the backend will be spent on the model. So let's focus on the backend model layer first. So we go to our source story, our source folder, the model module, and we are going to look at the project.rs. That is a good starting point. So the way the code design works is we have this entity, this model object. And we have two in this application, which is a project, which was the thing on the left, and the task, which is a project can have multiple tasks. And so here, if we look at the project, we have 5 constructs, and the first one is a project data type. And that is what is going to be sent back to the front end. Then after we have 2 related data type, which is a project for create and project for update. So every time there is application code that want to create or update a project, those are the types being used. And splitting them early is actually makes things much simpler down the road. And then we have another data type, which is a project filter, and those are filtered when we want to list the projects. And then we have our project BMC, which stands for Project Backend Model Controller. So the design here is that all of the application code that want to access either read, query, project elements, or update project elements has to go through the model controller, through the project model controller. And in the front end, we have a project FMC, which is mostly almost a pass-through to the project BMC. So let's extend these codes here to understand. So if we extend the project type, we see that project is extremely simple for now. You just have ID, name, and seed time. The ID is set by the store. The name is set when the user creates a new project or update it. And the seed time is also created at the store level. And right now, just to make things simple, they are all strings. This object is serialized from CRD. And the reason why it's not deserialized as well is because the frontend never sends that to the backend. This is only a type which is used to send the model back to the frontend. So here we are being minimalistic in what we derive. And then we use TS, which is a cool crate, which is TSRS, which allows us to create the TypeScript type from this struct and place it over there. So this way, our Rust types is basically the source of truth, and then we create those bindings that can be used on the TypeScript side. Now, a project needs to come from the database object, and so we have a try from, and that is from a serial data type object for the project. And that will return a result of project, and we'll use our application error that we have over there as an error type. Now, if we look at our project for create, we have a very similar thing. So we have a project for create, and that just takes the name. And as we can see, the name is required when we create a project, because creating a project without a name wouldn't really make sense. And for this type, we just need to be deserialized, because that will come from the front end. And then for this one, we just have a from. We don't need a try from because it won't fail, because project is more constrained than value. So we have just a from, project for create, for value. And that comes from a simple B-tree map. So there's no magic over there. And then we have our creatable, which is a trait for project for create. And that is a pattern that we are following for our store. So the store will require the type to implement creatable. And the creatable constraint is just saying that you need to have a from for value. And so this way, all the types that we want to make creatable will have to implement this trait. So everything is intent driven. Now, if we go to our project for update, extremely similar. We have our project for update, which will come from the front end only. So that's why we have this serialized. We don't need to serialize it. And then in this case, we just have name, which is obviously optional. And this is what we use above here, which is keep serializing none, which allows everything to be by default truly optional on the static side, such as you don't have to annotate every properties. And the cool thing is that gets picked up by the TSRS as well. So then after on the TypeScript type is very clean. And then same pattern as the create, we have the from project to value, and then we have our patchable trait for the project for create. Our filter is very similar. So we have a project filter, just deserialize, and we have an option name. Today is just a string, so it's a little bit silly in a way. It has to have a hard match. But later we can have more complex structure where you have an operator as well as a value. But for now, they are exact match. And that is what allows us to take a project filter to go to a value. And we follow the same pattern where we have filterable for project filter. And we're going to see how those work later in the store layer. So now we're ready to go to our project backend model controller, our project BMC. So first, the design is to be a unit struct, meaning a struct with no properties, no data whatsoever. And for now, the design is just to have associated functions that doesn't take self. So it makes the thing simpler, and the state will be carried over the context, which we're going to talk about later. By design and best practice, all of the BMC will have an entity const, which will be basically the name of the table. And then we have our CRUD associated functions, the get, the create, the update, the delete, and the list. If we click on the get one, the key pattern here is as a first argument is that we are taking a context. And that will be true for all BMC functions. And this context is where we're going to have the data store and all of the states that are needed to make a request happen. So that allows us to have the BMC stateless in a way. Then it takes the ID, and by default in SurrealDB, the ID is a string, which is a table name, colon, a unique ID. So we're going to follow this pattern. And then we're calling the BMC get, which actually comes from our BMC base. So that allows us to reuse common implementation for all of the CRUD. And then inside the project BMC, if we wanted to, we could implement custom BMC functions. So in the BMC get, we're going just to pass the CTX, the entity, and then the ID. By the way, here we don't need to have the reference. And then we're going to await. And now if we get a quick peek at the base implementation, we see that the base implementation is a generic function over E, which is our entity model, which is going to be the result. And E has to implement the try from, the object, which comes from the database, and with the error of the crate. So that is what we did in our project.rs. And then we are just calling CTX, the get store, which is coming from our store layer, and we'll see that later. And then we are just calling exec get. So that is a function that we have for this crate that wraps SurrealDB into the APIs that we want to expose. And then we give the ID. Again, here we don't need to put the reference. And then we do await and we do the try into. And so with this pattern here, we have a simple base implementation that can be reused across all of the BMCs, and everything is async from the get-go. So if we go back to our project, that is our BMC get. And then the create, very similar, takes the CTX. And then data is our project for create. It will return a model mutate result data, which is the design of this application is just the ID of what has been mutated. So this way we keep it light, and if the frontend or the application code wants to get more information, then they can call a get. And then we call the BMC create, and we pass those informations. Same thing for the update, very similar, but this time we have the ID and the data, and then we just call the BMC update. The delete, very similar, and the list, very similar, with this time the filter. And then every time when we call the BMC list, they are function, they don't have any constant to know which table, so we make sure to give the entity type, which is our table name, and that will return a result of that project. And then that's it. That is the gist of the model layer, those 5 constructs. And we can reuse base implementation functions like this way, and eventually as the code matures, trait can be implemented if it's really needed. But the goal here is with function and generics, you can go a long way. So the pattern here is that any main entity will have these 5 constructs. So for example, if we go and look at the task model, we have the same 5 constructs. It's also reusing the base implementation, the functions. And if we take a little peek at the task type, we're going to see that we have more properties. So we still have the ID and the ctime. So this is a little bit of fixture of a model. And then in this case, we always have a project ID. And then we have the task specific properties like done, title, description, or whatever. So now we can go to the store layer. So if we go to the mod.rs inside the store layer, and we expand the imports, first we have the prelude. So that is a pattern that allows us to have a very minimalistic set of constructs like result, error, and few more things that we'll be reusing across all our code. And then we have the import for the SurrealDB's constructs. In the module directory, we have some more helpers. We're not going to go through those, but that allows us to do some type translation. And then we have our creatable, patchable, and filterable. And as we can see, it's very simple. It's just required to have the into value. But that allows us at the store level to say, well, only types that are marked as creatable can be used in the create API. So now if we go down and we expand our struct for the store, this is where we have the DS, data store, and the sessions. And both of these objects are from the SurrealDB. And then in our implementation, we have our new that basically creates the store. And then we have our associated functions that perform the SurrealDB queries. And those are basically the CRUDs. Now it's important to note that as a store layer, we do not know about project, task, or any model objects. What we know is about creatable, patchable, and filterable. And we know how to return objects, serial object, which is like a record of a database in a way, or vector of objects and IDs. And now if we expand our exec get, we get our SQL, which is SurrealDB query language, with our $th, we're going to see how that works, which basically come from our TID. And then we build our parameters, our vars. We create a map, which is th, so that name needs to match the $th over there. And then thing, which is going to parse our TID into the appropriate type. And then we just call our DS, SurrealDB data store. We call the function execute, which comes from SurrealDB. We give our SQL, our session, and then our var. Then we have true, which means that if the table doesn't exist, it will throw an error. And in this case is what we want. That will return a list of results. We just need to take the first one. And then our goal is to return a result of object. And that is where we're going to use a new type pattern with a wrapper type, which we're going to call W. Because if we want to implement the try from value to object, that gives us the try into. The problem is the try from is external to our trait. First return a value which is also external to our trait, and we want to make it as an object which is also external to our trait. And Rust doesn't allow to implement external trait on external types. So to get the try into, you need to have a new type pattern with W, which is a type which belongs to our crate, to our application. So if we click on it quickly, we go to our prelude. Our prelude is very small, as we can see. And then one thing that it has this type, which is W. It could have been wrapper, doesn't really matter. Takes a type T, has T public, and that's it. It doesn't have anything else. And that allows us to wrap whatever type we want, such as we can implement try from for any types, basically. And that is part of the new type pattern of Rust. So if we go back to our store module, that will allow us to return a result of object. So now we can go to our exec create. Very similar. We have our SQL, which is create, the table, which comes from our TB, which comes from our BMC, and then we have our content, which is the data. And then we return ID. Now we're going to create our data object to give to our data store executor. We're using the new type pattern. We're doing the data into and try into. And we can use the data into because T implements creatable and creatable implements into value. And then as part of our create store logic, what we want to do is to create the C time. And we don't want the BMC to worry about the C time. In a way, the creation time is a store business, is what the store will add to any objects that get created in the database. So now that we have the C time in now, we're just going to insert it into the object. And then we're going to create our vars with the TB will be the table name and the data will be what we created. So the vars always needs to match the property you put in $signs. That is similar to a prepared statement in Postgres or other databases. And then what you do is a data store, execute SQL, same thing, you give the var. In this case, we're going to set strict to false because we want to create the schema on the fly if the table doesn't already exist. Obviously, we can be more strict if we wanted, but that is a pattern that we're going to follow for now. Then we get our first value, and then we're going to get the ID of the first value and return that as a string. So again, the pattern here is we just return the ID of the object created. Now the merge is going to be very similar, takes a patchable, the ID and the data, and we're going to use update, the thing, which is a TID basically, and then we're going to use the SurrealDB command merge, which is going to allow us to just merge the data to an existing one. We give our data and we return ID as our pattern. Create our var, we do the execute, we get the first result, and then we return the data. Very simple. The delete, very similar. And then the select, that is where it gets a little bit interesting, is we're doing a select similar to the get, but we're going to create a var, we're going to make it mutable, because then we're going to apply the filter. And so if there is some filters, we're going to add a where clause, and we're going to add the name value pair. And the important point here is we're not creating a big long SQL statement. We're using parameterized statement. We're going to hardcode our order C time. Here you don't really need to format and do the reference because it's a static string. And then we're going to execute, get the first result. We get the array from the first result. We use a new type pattern over there. And then each element, we're going to translate them into object, which then will translate into our model type. And then that's it. That is the beginning of our store layer. Obviously, as time grows, that will become more and more functionally complete, but that is a very good base to start with. Now we can look a little bit how our BMC base is calling the store. So for example, on the create, we can see that we're just doing the exec. And the most important things here is that our model is responsible for firing the model events. And this is probably the most important of the whole architecture, because with this architecture, everything is event-based from the start. So the UI sends an update command, and it's a little bit a send and forget. And the backend will fire these model events that will propagate back to the frontend, such as the frontend can update itself. And that is the key to have scalable code and to not paint yourself into a state management nightmare. Now, if we go and see how the fire model event is implemented, it's very simple. It's just normalize the event into something that can be consumed on the client side. We have the concept of hub events on the client side. We're using CTX, emit event. We're going to fire on the hub model, and then we give the topic, which is the entity type, the label, which is the action, and the data, which is going to be the ID in these mutable calls. Then for completeness, if we go back to our CTX, we see that we have our store, our app handle from Tauri. That is where we create our CTX from app handle. And here we have our new that takes the app handle state of our store. We're going to see that later. And then it does a clone. And then we also keep the app handle when we want to emit the events. And that is where the event starts with, which we are just using the Tauri, emit all events. And then we have our guest store, which is used to update the store. So for now, our event layer is actually very simple, because all of the hard work to have an event base between your backend and the frontend has been taken care of by Tauri. Eventually, the event layer can become bigger as the backend services might communicate between them. Because an event layer is not only backend to frontend or frontend to backend, but is also backend to backend. And so finally, to kind of close the loop, we can go to our main.rs. And if we go to our main, which is async, we see that we are creating the store, we are seeding our database, and then we are calling Tauri. Very simple. The way that we add the store to the state, such as we can get it from the app handle, is with manage store. So that will put our store object over there. And then we have our invoke handler, where we have all our handlers for the IPC layer, which we're going to click later. And those are the Tauri handlers that make the bridge between the frontend and the backend. So if we go to the IPC layer, that is all where we have our procedure calls logic. And if you go to the module, we get our param, project response, and we get all our re-exports, such as the consumer of this module doesn't have to know where things are. And then for project, for example, the get project is very simple. We get the context, and if we have the context, we call the methods, and then we return. And if it's not, then we return an error. And right now, the handle needs to return a specific type because we want to have a specific format, so we don't want to send an error back. And then for the create, very similar, we call the BMC create, and the params will be our create params for the IPC. As a generic, we'll take the project create. And then we have an update param that take a project for update, and then we call our BMC update. And then our task will be very similar. And that's it. So that was pretty big, but that was almost a full overview of the backend code. Now let's have some fun. So if we do awesome app dev, that will start our dev session. Then we see our cool little apps. So that is pretty cool. But what we want is we want it on the right. So the way we do that is we go to our Tauri.toml. We have all of this section, and in the Tauri's windows, in our first window, I am going to put this positioning, kind of personal to my desktop. That will allow me to have the application on the top right. And I also put always on top, such as I can code and see what's happening. So now I press save, and this is where the Tauri magic happened. Detect it, rebuild it, and reposition it. Then that's it. I have my cool little application over there, and I can code on the left, and I still have my app. That is pretty cool already. So now at the beginning of the video, we saw how we prefixed all of the project by ++, by changing what comes from the database. So how do we do that? Well, we could go to the store, but then it will be very generic for any types, or we can go to our model layer, and we go to our project, and that is where we're going to change what is coming back from the database. And for that, you guessed it, we go to our try from, object come from SurrealDB, and project is what we are sending back to the frontend. So in the try from, this is where we take the data, the property name from the object. And so what we want to do is to prefix it. So we're going to do a format, ++, and then we are going to give our data there. Now, because the format can take multiple types, we need to tell which type we want to have from name. And the way to do that is our trait allows us to be turbofish, so we're going to say we want string. We press save, then it will recompile, and boom, we have our app over there. And if we create a new project, it will have the ++, because basically that is what is coming back from our database, and everything works. And we have the ++ in every places where we display the project, because that is what the backend is sending back to the UI. Okay, so let's remove that, such as we can go back to a normal app. And now we're going to look at the UI. So first on the UI, we have the CSS files. And actually, when you are going to develop application, you are going to spend quite a bit of time on the CSS side. So it has to be treated as real code. So those is all of the infrastructure kind of CSS. We're using CSS vars. And then on the view side, we have all our view CSS. And we are following the same naming convention that we're following for our TypeScript files. For the main custom elements, we have the file name matching the tag name. The main component is the app-v, which is the whole application. And in fact, if you look at our index.html, which get bundled into the application, or served by our local host when we are in local development, our body just have only one tag, which is app-v, the initialization of our applications. And so if we go to our app-v CSS, or CSS, then we can just add our red border like we saw at the beginning. Press save, and it just get updated super fast. Obviously, we don't want that, so let's remove that. And then the naming convention is our tag will be -v for the bigger view, -c for the smaller component, and sometimes we can have our own suffix for some specific component types. So for example, for our data table, we're going to have -dt. And so this best practice is very nice because you can see your components and the type of component you have. So sometimes a task might have different component types as well. Now, if we go to our TypeScript source code, we have our model, view, and event layer, as we've seen before. So now if we go to the model, let's close the app. The model is actually extremely simple in the front end. It's almost like a pass-through. So what we're doing is we have a base FMC for front-end model controller that takes 3 generic, M for the entity model, C for the create type, so project for create, for example, and U for project for update. So that allows us to really type everything at the FMC level. And our base FMC, which will be used and will be inherited, so we're going to use inheritance in this case, is extremely simple. We just have our CRUD API, but we have the get, and it just do an IPC invoke. And then the IPC invoke will come from our IPC layer over there. And it's going to be very simple here, just to normalize the calls to Tauri. And then for every entity type, we have a FMC. So we have a project front-end model controller that specifies the types for the specific type, and as well as implementing some custom function. And here the list is part of the leaf of the FMCs, but eventually that will be put upstream. On the view side, this is where most of the front-end code will be. We're following the custom elements. So the first one is the app-v, as we have seen before. Click on the app-v. We have our class app-view, which extend base HTML element. So we're using a macro library, which is called DOM native, which I happen to have created and used for many years. And that is just some utilities to be able to use native web components and making them a little bit more TypeScript friendly. That will just extend the DOM HTML element. And we have a TypeScript decorator to define this app_view class as the app-v tag. And this is exactly the same as custom elements define app_view. So again, this is not a framework because it doesn't change the application model. It's just a way to make the things a little bit more convenient. The most important things here is a pattern, and it's not the tech stack. And the pattern is we have our HTML usually as document fragment. So that is, for example, the structure of our app view. We have the header, we have the icon, we have the title, we have the nav-v, which is on the left, and the main, which will have our main application components. And then the JS tag templates, literal, which come from DOM native, will take that and just create a document fragment. So all of that is pure JavaScript and DOM. Now, if we build the application, for example, I'm going to start the application on the right. And now let's say that I'm going to rename my app Cool App. Press save, and it's going to make the change on the right. And then I have my Cool App. So one thing which is very cool with Tauri as well is because we're using web technology, web views, you can actually extend it, and we're going to right click on it and say inspect element. And boom, we have the developer tools within a desktop app. So for example, we can see the structure of our application. We have our app_v, which have the header, which then have the nav-v component, which in turn inside have a header and a section for the content. And then inside our main, we have a project-v component that we see on the left. And if we expand it, we can see that we have the header and we have a section with our data table. And then that's it. That is the basic of the app layout. And everything is completely frameworkless and has been created on the go as the component initialize themselves. So let's close the application right now. And we're going to look at how our native web components looks like. The three main sections is a key ELs, app events, and UI events. The key ELs are the key elements that will be reused through the lifecycle of the application. And so in this app view design, the only thing that really matters is a main EL, which will be used to put the new project custom element. Then the app event, those are non-DOM events. There are events that are for the application. So one of a good example is for the route events. And the way it works is we have just the decorator on hub that come from DOM native. And it's just a simple pub sub where you have the hub and then you have the topic. And so you have a 3-level down, which is hub, topic, label. And so for route, we just care about the topic. And then the handler could be async or not. In this case, we want it to be async. And then within the code, we can get the project ID, which is one of the property of the route, from the current route. And then depending if we have one or not, we can update the UI accordingly. So for example, we are going to get the project with our project ID. And then we are going to create the project-v view, and we are going to add it to the view. Then the UI events, they are more like regular DOM events. So for example, here we have a TypeScript decorator, which is basically just a shorthand to do a add event listener on pointer up. And when we get the pointer up on app view, we are trying to match it with the selector. And if it does match, then we are calling the on menu click. And then in this case, it's very simple. We're just going to toggle the min nav, which is actually not really implemented in the CSS as of this day, but it might be when you watch this video. And then we have the init method, and that will be called by base HTML elements once on first connected callback. And so in this case, we are going to create our content where we're going to import our document fragment, and we are going to clone it. Then we are going to extract the main EL, such as we can keep it for all the time, such as we don't have to query it again. And then we are just going to beautify our H1. So this is a little hack for the demo in a way, because I wanted to make sure that whatever name you do, you had this 2-color business. But obviously here you should have your logo or something. And then we just call a DOM API, which is this replace children and with our document fragment. and that will replace the content of the application. And to understand how things work, at the beginning of the video, what we did is we displayed this exclamation mark on the title of each task. So how did we do that? Well, this component that displays the task is actually our task-dt for data table. So if we click on it, we have the same structure, which is our HTML fixtures, and those are static HTML, and they are document fragments. So we have one for the header, and then we have one for each of the rows. So for example, if we change our header for the title to AA, then the table update over there. Obviously we want title, we save, and then it's updated again. Now what we want is, how do we add the exclamation mark? It wouldn't make sense to add it here because that will be set dynamically for each row. And so we have two components in this file. We have the main one, which is our task data table. Let's remove the left side such as we can see a little bit more. And then if we go down, we have our task row. That is, each row is this custom element. And in our task row, we have two main sections. One is the data, and then the other one is the key elements. And then we have the init and update below. So now on the data, this is how the data gets set. We're setting the data, and then if it's not the same as the previous one, we're calling update. So now that we have this logic, we know where we need to go. We have the init, which is basically just doing the import node as we have seen before. And then we know that in update, this is where things happen. And if we go to the update of the row, we can see that we have our title EL, test content, that is set at this point here. And so in this case, we're just going to add this exclamation mark, press save, and then boom, we have that. And then if we create a new task, that will show as well, because this is just a display artifact. So we're going to remove it. And so the question is, how does this check EL, title, and info EL came from? And that is following our pattern, which is basically our key elements that we have over there. And the pattern is that we are initializing them in the init, and we scan the child, one or more children. And this is a very fast way of scanning a flat level DOM structure. And then once you have that, you have everything to do the update. Now the question is, when we are changing state, for example, if we are changing here the done state, how does it update? Because actually our task row doesn't have anything. But the truth is, that is where the O1 pattern comes from. Rather to put all of the handler and having the rows being too smart, we are keeping the row as dumb as possible. So the data, the task data table, is the one that is smart about this. And this is where we have our UI event, and you can see that it's listening to change event from our dcheck component. And this dcheck is a DOM UI native component, but it could be anything else. It doesn't really matter. You are listening the bubble events of any rows, and then you have a way in your handler, which is on task shed click, to get which task model it is. And then after you can update by calling the FMC. And then the most important is to call and forget. What you don't want is to update the UI when you mutate the data. What you want is to call and forget, so at the end, we are not updating the UI, and we are going to wait until the event, the data, the model events come back to update the UI. And the way we do that, it's extremely clean. You go to your app event section, and that is where, with our hub pub sub, that we can listen to model events for task create, for task delete, and for task update. So for example, on the update side, what is happening is we are getting the new task by calling the task FMC. We are getting the ID from our type here, which is model mutate result data. And then we are calling all, which is basically a shorthand for document query selector. And we are querying on our task row. We have encoded the task ID as part of the class. And then we get our task row object, EL, and we can set the property task to the new task. And then that's it. That will update the task row. So in a way, a task row is relatively dumb. It just knows how to update itself and doesn't have any events or doesn't even know where to get the data. And all of the smartness is at the container level, which is the task data table. So for example, for the create, we just call this update of the task data table, which basically will update everything. Because when you add something, if you sort by name or whatever, the sorting might be different. And the source of truth is always the backend. And that's it from an application standpoint. Now everything else is how to wire all of these things. And so we're using Postcss, and then we're using Rollup to bundle our TypeScript into one JavaScript file. We also have a sketchdev.config.js, so that is something I've created, which basically generates icons from the app-assets.sketch. That is completely optional. I just put it there if you want to use it, but the icons are already there. That will be probably the subject of another video, but everything is already included. And then obviously in our source UI, we're using tsconfig.json because our frontend is TypeScript. And then last but not least, we have the Awesome.toml. So the whole build script is fully customizable and it's just runners. And we see here that we are calling the npm install. And here we are calling the Tauri icons, the cargo build, and then the pcss builder, which we are marking as concurrent because we have the watch mode. And then we have the and all on exit, meaning that when this process ends, then everybody else ends. So that allows that when you close the windows or anything, we don't have leftover processes. So then we have the same thing for Rollup, for localhost, which allows us to have the reload of the UI, and then for Tauri as well. And all on exit to make sure that when you close a window, everything else is closed as well. So that was quite a bit of information, but if you're still here, now you have a very good understanding how to build awesome desktop application with Tauri, SurrealDB, and Rust. We're going to do many more videos about Awesome App and how to build awesome application, so feel free to follow, and until next one, happy coding.